while the online homework is an extra credit opportunity, which basically, if you do all of it, if you do all the chapters that we end up doing in class, you'll get a 3 percentage point grade bump on your final grade. And then however many chapters of that you do, which I'm grading for completion mostly, so I bumped the passing rate or passing threshold of those down to 40%, because that online homework is annoying. But I have an additional option for you. So I'm not going to double the amount of extra credit you do if you do both of these. However, I'm going to start posting a list of questions from the book. So if you go into the chapters and you go to problems, there's a bunch of problems back there. I like those way better. You have access to all of the solutions with explanations of them. And I wasn't gonna grade homework for accuracy anyway, because there's no good reason to. It's just, I don't know, it's just, here, have some extra credit for some good ideas for studying. So I'm gonna make those due the same time the online homeworks are due, which is midnight the night after you take your final exam. If I can set up the thing on Blackboard that I want to. So I want to set it up as a bunch of assignments on Blackboard not Blackboard, what?
Canvas.
Canvas, it's not Blackboard, I don't know. I've used six different ones. What do we used to have here before this was Canvas? Canopy, yeah, okay. I knew that there was another C word, and I always am looking for whenever I try and find Catalyst, I think of Catalyst and I'm like, no, that's not the name of what I'm looking for, and it is, but Canopy's the one I always forget. So I'm gonna try and put it on Canvas, that's our current one, okay, Canvas. Put them on as assignments, where basically you can submit attachments of pictures or PDF or whatever, and then if you just send, take pictures of, or I don't know, if you don't write on paper, print as PDF or whatever, of your homework that you do from the book problems that I list, then you can turn it on there, and that is instead of the online homework. So you can mix and match one homework from each chapter. I mean, you can turn in both from each chapter, but I'm not doubling each credit, because the whole point of this is to make it so you can still benefit without having to fight with technology. So, but yeah, so if you've already done a bunch of the online extra credit or online homework, you can submit that and just do book problems for later chapters, whatever you want. But yeah, and this is homework completion points. It's all or, I mean, if you turn it in, you get all the points, so yeah. Cool. I think that's it, besides the fact that I don't really trust that we've got, so it says we've got 64 slides left. That's not exactly true, because a lot of these slides are a blank slide and then a hidden slide right next to it with or three next to it with mechanisms that we're gonna go over. But still, I don't think we're gonna start chapter 17 today. I hope tomorrow we can finish chapter 16. But we're gonna see. Your exam will still be, a week from yesterday? Monday. And we're just gonna adjust whatever's on there. skipped over this guy yesterday when we were talking about acetals, because it kind of looks like just another protecting group and turning a, like protecting a carbonyl, right? Or at least when I glanced at it, it looked like that. And I was like, okay, that's fine. This is using an acetal to protect an alcohol. So it, I don't know, I guess gets to belong in this chapter since now we finally know how to make acetals. But yeah, this is a, I'm not gonna make you know dihydropyran just by name, like I'll show it to you if you have to do this, but yeah, this is a protecting group you can use on an alcohol. That's the thing. You have to use an acid catalyst to get it on there. However, once you get it on there, it's stable in neutral and basic solution. So you can make this and then neutralize it and then make a Grignard reagent with your protected alcohol and then do the Grignard, and then in your workup, you'll use dilute aqueous acid anyway to work up your Grignard reagent, so perfect. That also regenerates your primary or secondary alcohol. So that's another protecting group you can use. Let's see. So let's talk about nitrogen nucleophiles. And don't ask me why they're giant. I tried to get rid of these giant spaces after every degree sign. I don't know why they're there, but like, whatever font they have going on here, and like, getting rid of it and just entering, like, putting in the degree sign even with the alt code is just like, okay, degree sign tab.
They don't even look that giant on the laptop.
They don't?
You're like, no, on mine they look
Okay. I always thought that these just looked really
That's so weird that
funny.
it would change formatting.
Yeah. Well, maybe I just have old computers and
Maybe.
yours understands the font in a way that mine doesn't. Because I mean, this is a shitty laptop that the library gave me when I worked for them, and I'm going to give it back, but like after I finish teaching here, because I don't have a laptop, I have a hand-me-down desktop. And you cannot trust these computers. You really can't. I learned that. So, nitrogen nucleophiles. This is going to be really similar to. What are you getting caught on? Why are you so upset with me? This is going to be really similar to what we've been doing with oxygen nucleophiles, just because, well, we're doing nucleophiles and carbonyls, so like there's pretty much two ways to do that, right? We can do base catalyzed, in which case we don't have to mess with the carbonyl, it stays the way it is. The base might change our nucleophile, the thing with electrons that attacks, and then you attack, and you pick up the electrons from the double bond, get a negative charge in your oxygen, and then eventually you work that up and you protonate it. Or you can do acid catalyzed, in which case usually you, in which case you protonate your carbonyl alcohol to make that carbon an even better electrophile, and then you attack, but you don't get a negative charge. You saved yourself from those because it's acid. So we are gonna do this though, this mechanism. So ammonia, aliphatic amines. Aliphatic is not aromatic. It's just what that means. And aromatic amines. So primary, as long as you've got a primary amine, you can react it with a carbonyl group of aldehydes and ketones and get an imine Schiff base. So, yeah, I've heard it called Schiff base. I've heard it called imine. You just have to be really specific about your pronunciation if you're gonna call it an imine or writing stuff down, because, you know, I'm gonna try really hard to not say amine or say it in any way that sounds the same as that. But anyway, basically, what we can do is we do our attack, and then we end up kicking off water and replacing that oxygen with a nitrogen. Right there. That's an imine. So let's do that as a mechanism, because those are great. Let's see. Okay, yeah, and these are acid catalyzed? No, this one breaks the rules, and I'm trying to make sure that I know why. Is it because you only add, maybe it's because you only add acid in the workup. All right, we're gonna do this, and this one is going to break the rules of, can I have negative charges or positive charges? It's just, when we have everything's oxygens, we're good. It follows these rules. When it's our nucleophile is a nitrogen, and is in the form of an imine. I'll look that up and see if that's if there's a specific reason that it's like this. But all I can think is that you need it to be slightly acidic just to make the OH into a leaving group of H2O, so it'll actually leave, but that primary amines are going to be strong enough nucleophiles to attack the carbonyl without actually protonating it to activate it. I think that's what this is.
So you don't need the acid?
So I think we're gonna need the acid to finish the reaction at the end, to kick off the water. But I'm gonna break the rules about no negative charges. And I'm doing that because I want to do it the same way as they have it in your book, so that when you study things, it's not two different ways. But yeah. All right, so let's start. Wait, gotta get all my colors going because I have to draw the carbon that we. The carbonyl carbon. Okay. So, quick question. When I use nucleophile electrophile, is that useful terminology to you? Like, when I say it, you immediately go, oh, nucleophile, the thing with lots of electrons. Oh, electrophile, the thing that wants electrons. Or is it kind of, yes, we've been using it for a semester already, but our semester was a month, so maybe just use those terms and then also remind us what they use verbally while you use them. Can I get like a yes, remind us what they mean sometimes while you're talking, and a no, I'm good, I remember this? Okay. All right, I'll do that sometimes just to kind of make sure that I'm not, because, let's see. And I'm gonna do, there. That'll help too. Because like nucleophile and electrophile are really useful terms, like it's useful to talk about them, but one of my favorite organic classes was my master's organic class when he like took all of that vocabulary and threw it out the window and nobody was allowed to use that. So you just had to say, well, there's more electron density on this and there's not enough electron density on this. And so more electron density attacks less electron density. And it was a lot of words because we had to write like why, like this whole long thing for everything we solved. But it was useful to think about it that way. So I'm gonna make sure we're not, I don't know, losing the meaning in the, okay, wait. Oh yeah, we're good. Down to left here. Okay, we're gonna take this, and we're gonna do okay. Nitrogen nucleophile. We've got a nice lone pair here. We've got a polar bond here. So attack. Kick that up because we never leave our carbon with 5 bonds. That makes puppies cry. And this is reversible because, I don't know, a lot of this stuff is. I mean, Grignard reagents are like aggressive enough, and organolithium and Gilman reagents. Those are aggressive enough that they're not reversible. Most of this other stuff is with carbonyl chemistry. Yeah. Just because like nitrogens, oxygens, I don't know. There's nothing that's like a carbon that's like, no, if you try and deprotonate me, I am pKa 50 and I'm not having it. So they're all kind of in the same realm-ish. Okay, let's draw this thing. That. Okay, so we attacked and we made a negative charge, and that's why when it says when we've got that H plus on there, I'm not sure if that's just for like a workup at the end or something, because like this is definitely strong enough to attack it like this, and this is the way your book has it, so it doesn't seem to need activation. But anyway. All right, so after this, then we take another mole of this, and it's not red this time because it's not going to act like a nucleophile. But what's going to happen is this hanging out here is a convenient enough base, right? Because, I mean, those are somewhat basic amines, not like super, super basic, but they're somewhat basic, useful enough. What's our, I should just print out a pKa table so that I can look at that without pulling that up. Oh, I have it on Canvas. Can somebody pull up the pKa table? Because I want to talk about pKa while we do this, but yeah, so we, no, and then I drew this anyway. I drew exactly what I didn't want to draw. What am I doing? Okay, sorry. I'm going to do this so that it's oriented in a way that's more convenient for me. Okay. This guy's a convenient enough base. Why I made lone pairs attack a nitrogen, I will never know, but maybe after caffeine kicks in, I will stop doing such things. So this one is going to deprotonate our unhappy nitrogen there, our positively charged nitrogen, and give us, in a reversible reaction, what are the colors on here? He's got his lone pair back. Yeah? Is it okay if I pretty much only draw lone pairs when we're using them? Okay, so like, when I leave this, we know we've got, like, there's one bond, so there must be 3 lone pairs. We're good with this, yes?